Okay, this is the in-class review for Chapter 3. Again, you have another one online that you can do, but this is the video for this one we're doing in class. For number 1, it says, refer to the figure and identify the name of the angle. So we take a look at this, and it's asking for angles 1 and angle 5. Okay, so for angles 1 and 5, these are corresponding angles. Okay, looking at the next question for 2 and 7. 2 and 7, here's angle 2 and there is angle 7, and here is a Z that's formed. These two lines are parallel because it's indicated that they're parallel, so these are alternate interior angles. Okay, moving on to the next question. For this one, they're asking about angles 5 and 6. So let's move some of this stuff. So angle 5 is right here. Angle 8, 5 and 8. So here is 5, there is 8. These are vertical angles. So we went ahead and named all three. And then the next one, angle 1 and angle 8. Angle 1 is over here. Angle 8 is over here. Here is a Z, and these are alternate interiors, and we take the opposites, so these would be alternate exterior angles. For number 2, we are asked to find the measure of angle 1 and angle 2. Well, taking a look at this first one, this is 65 degrees. These are vertical angles, so the measure of angle 1 will be 65 degrees as well. Now, moving on to angle 2. Since these two lines are parallel and it's indicated by those arrowheads, I can make a Z here, and the opposites, the vertical angles of the Z is angle 2, and the vertical of this interior for these alternate interiors, so these two are the alternate interiors, and the verticals are 1 and 2, so that means they're alternate exterior, and since these two lines are parallel, then those two angles will be congruent, so the measure of angle 2 will also be 65 degrees. Now, another way you could have done it is these are right here, parallel, so these are corresponding angles in here. This is a corresponding angle to that one. It's 65 degrees. So there's more than one way to do these. Okay, moving on to the next question. Over here, I've got angle 1 and angle 2. Well, these are parallel, which would mean angle 1 is alternate interior to the 131 degrees, so the measure of angle 1 is 131 degrees as well. Again, you could have done this a different way, but we went ahead and chose to do it using alternate interior angles. To find the measure of angle 2, I know that these, again, as we said, are parallel. So these consecutive interior, or we can call them same side interior, angles 1 and angle 2 will be, they are supplementary, so they add up to be 180. Another way to do it, well, this is a straight line. If this is 131 degrees, these two, 131 plus angle 2, have to add up to be 180. So there is more than one way. Regardless, we're going to say 180 minus the 131, which would give me the measure of angle 2 as equaling 49 degrees. Okay, moving on to the next question. Let's move this up. And we have to, on this next one, decide whether there's enough information to prove that J is parallel to K. If so, state which theorem. So here's J right here, and this is K in this one. And I need to see if these are parallel. Well, if this is 113, I know that this right here will be 113 as well because those are vertical angles. These are same side interior, consecutive interior. If J was parallel to K, then those two have to add up to be 180. Is 113 plus 67 180? Yes, it is. So that means J is parallel to K, and we used same side interior, or you can call it consecutive interior angles. Okay, next question. Looking at these, here's J, there's K, these are both right angles. So yes, J is going to be parallel to K because both form right angles, so these are corresponding angles. So it would be the converse, we could say, just like here, we could say the converse of consecutive interior. This would be the converse of corresponding angles. Again, the converse tells us things are parallel. Okay, moving on to number 4, we have to find x in each of them. Since these are parallel, we are told that those are parallel. These two will be alternate exterior angles and they will be congruent. So I could say 3x plus 32 equals 5x minus 8. If you didn't see them as alternate exterior, you could do vertical angles here, vertical angles there, and then these would be alternate interior. That's another way. So setting these equal to each other, or you could have just put the 3x plus 32 in this spot and done it with corresponding. So again, there's more than one way to do this. I'm going to subtract 3x from each side. So I'll get 2x here, add 8 to each side, equals the 40. So 40 is equal to 2x. X is going to be 20. Okay, so taking a look at this, these are same side interior, consecutive interior. So these are going to add up to be 180. So we're going to say 2x minus 10 plus the 4x plus 16 is the 180. So now let's combine these two to get 6x. And I'll combine the negative 10 plus 6 to get plus 16 to get plus 6 equals the 180. So 6x equals 174. X is going to be, X is going to be 29. Okay, so we ended up with x equals 29. You can plug the x in to double check your answer there. All right, so now moving on to number 5. Let's take a look at this. It says, in the figure, L is parallel to M. The measure of angle 1 is 95 degrees. So I'm going to go ahead and write that in here. The measure of angle 1 is 95 degrees. And the measure of angle 11 is twice the measure of angle 2. Okay, so I can go ahead and find what the measure of angle 2 is. It says find the measure of all the remaining angles. So the measure of angle 2, I know right away to be 180 minus 95. So 180 minus the 95 will give me 85. So 85 degrees, and that's 85 degrees. And I know that the measure of angle 11 is twice the measure of angle 2. So twice that will give me 170 degrees. So this is 170 degrees in there. Okay, so now that they gave me that L and M are parallel, I can find other remaining angles. So let's go ahead and list everyone on here. The measure of angle 3, the measure of angle 4, the measure of angle 5, the measure of angle 6, the measure of angle 7, the measure of angle 8. We'll continue here. The measure of angle 9, the measure of angle 10, 11 we've already gotten, the measure of angle 12, the measure of angle 13, the measure of angle 14, and last over here, the measure of angle 15. So let's go through and see if we could do each one of these. So if this is 170, I know that these two are parallel. So these are corresponding angles. The measure of angle 14 will be 170 degrees as well. So that's 170 degrees. The measure of angle 15 will be 10 degrees because this is a straight line and it's a linear pair. So the measure of angle 15 is 10 degrees. I know that the measure of angle 12 will be vertical to 14, so that's also going to be 170 degrees. And the measure of angle 13 will be vertical to 15, or you could say that it also forms a linear pair with angle 14, so that will be 10 degrees as well. So we've gotten all these in here, so that's 10, that's 170 degrees. So continuing on, since angle 2 is 85, I know that angle 6 over here, because these are corresponding angles, will be 85 degrees as well. Which makes angle 3, these are vertical angles right in here. Here's where they cross. Let me do it in another color right here, right here. So angle 3 will also be 85 degrees. Now, angle 1 is right in here, and angle 1 will be what 7 and 8 add up to be. So let's see if there's anything else we can find in the meantime. Okay, so at this point, when we take a look at everything that we're given, I know that 7 plus 8 plus the 3, that has to be 180, but same thing on the other side. 8 and 5 are congruent, those are vertical. 7 and 4 are congruent, those are vertical. 10 and 9 have to add up to be this 10 degrees here. So there isn't really enough information for me at this point with what you know to solve for the rest. So over here, we are just going to ignore these because you don't know how to do the rest yet. You will eventually be able possibly to piece some of this together using remote exterior, or possibly not. We may be stuck at this point with not enough information to finish it. But let's go ahead and move on to the next problem regardless. Okay, so move to the next page, and this is kind of what I was talking about with the remote interior and exterior, but this is what we're going to do. We have to solve for x and y. Over here, I know that y is right here, but y plus the 130 has to add up to be 180. So I know that this would have to be 50 degrees in here. Now, here's one thing that you should already know, is that a triangle adds up to be 180 degrees. So if I've got the 62 plus the 50, that's 112 degrees. That means we said y has to be 50 degrees. So that would mean that the measure of angle x would have to be 180 minus 112, which would be 68 degrees. All right, moving on to these. Write the equation of a line that passes through those 2 points. So we have our steps to write the equation of a line. This is a review from Algebra 1. First, we need to find the slope. Let's go ahead and label this x1, y1, and this point x2, y2. So our slope is going to be 8 minus 4 over 1 minus the negative 2. Remember, the slope is y2 minus y1 over x2 minus x1, which is the change in y over the change in x, and we represent it by saying the rise over the run. So over here, we said 8 minus 4, 1 minus negative 2, which becomes 4 over 3 as my slope. So now I could say y minus y1 equals m times x minus x1, and I'm using point slope formula. You could also do it with y equals mx plus b. Either way, I'm just going to go ahead and use this one, and I'll put in either one of these 2 points. It doesn't matter. We'll just use the first one. So y minus 4 equals 4/3 times x minus negative 2, so that'll be plus 2. I can clean this up on the test tomorrow. I'll let you leave it in this form. That's okay. If I asked for slope-intercept form, you would have to clean it up to look like that. Okay, moving on to the next problem. On this one, we have to write the equation of a line passing through this point, and we want it to be parallel to this. Since we want it to be parallel, that means the slopes have to be the same, so the slope has to be 1/2. In this problem, that's the slope. Parallel means same slope, so the slope will be 1/2. So y minus y1 equals m times x minus x1, and I know my slope has to be the same at 1/2, but I have a different x and y point. So my x and y point, we're going to use this one right here. So y minus 6 equals 1/2 x minus -2, so that would be x plus 2. Again, if you did it with y equals mx plus b, you could say y equals 1/2 x plus b. Then you would put in -2 for your x and 6 for your y and solve for this b variable. On the test tomorrow, again, I'm okay with you doing it like this and just leaving it in this form. All right, moving on to number 9. On this one, we need to decide if these lines are parallel, perpendicular, or if they coincide. So, looking at this, I need to find the slope of each one of these lines. So I'm going to go ahead and solve for y. On this first one, that just means subtracting the 2x. So I get y equals, I subtract 2x from each side, 2x plus 6. So here I know the slope is -2. On this one, I'm going to solve for y. So I'm going to divide everything by 3. So if I divide everything by 3 on this, I'll get y equals -2x plus 6. Again, the slope is -2. Well, right now I know that same slopes are parallel, but look at this. These intercepts are exactly the same. So these are just not only parallel, but they coincide. And what does that mean? The two lines are right on top of each other like that. So they're just multiples of each other, so the two lines coincide. They are right on top. Okay, for the next one, it says, right, what is the equation of a line that passes through this point, but now we want it perpendicular to this? So the first thing I need to know is the slope of this line. So we're going to solve this one for y. So y equals -2x plus 6. And since I want it to be perpendicular, I need a perpendicular slope. This slope right now is at -2. Perpendicular, I take the opposite of it and the reciprocal. So doing both of those things, the opposite would make it +2, the reciprocal would make it 1/2. That is the slope of a perpendicular line to this equation. So again, we'll just say y minus y1 equals m times x minus x1. I know the slope I need to use is 1/2, and here's the point that they tell me that it goes through. So we'll say y minus -1, so that's y plus 1, and then x minus -2, so that's x plus 2. Again, on tomorrow's test, I'm not going to care if you leave it in this form, point slope form, or y equals mx plus b form. I will take either one. Okay, let's move on to number 11. On number 11, this is partitioning. So, let's read through this and see what we can do. On this one it says, suppose you have a point A right there, point B right there, and wanted to place a point P along the segment from A to B so that it partitions the segment in a 3-to-1 ratio. What would the coordinates of point B be? So, if this is A and this is B right here, again, let me just demonstrate what's happening. These aren't the actual coordinates. I connect them along a segment. I want to put point P, so that's a 3-to-1 ratio. In other words, what you did, and you did this with the licorice, was you cut this segment into 4 parts, 4 equal parts. 1, 2, 3, 4. So if I take 3 of these parts, 3 of these equal parts, this is a 3-to-1 ratio. But now I need to know where this point P needs to be on a coordinate plane so that this happens. So, the other activity we did was we figured out how to do this. We said we would take these two, added up because I needed 4 equal parts. So this 3 plus 1 gave me the 4 equal parts that I need. And I want 3 out of 4 of those in this direction, and 3 out of 4 of those in that direction to find where point P is. So I need 3/4 of the run, this is the run, plus my original x1 value, this is my x1, and I need 3/4 of the rise plus my original y1 value to get my new coordinate for P. Well, let's find the run from A to B. So the run from A to B is going to be x2 minus x1, which is 3 minus negative 2, which is 5. So I need 3/4 times 5 plus my x1 value, which is at negative 2. Okay, so simplifying this, I end up with 15/4 plus negative 2, and you can find a common denominator and work this out, and you'll get 1 and 3/4. So this is my x-coordinate for point P. Now let's do the other one. The rise, I'm going from 8 to 12. So this is at 8, I'm going up to 12. That rise is going to be, over here, we'll say y2 minus y1, which is 12 minus the 8, which is 4. So my rise is 4. So 3/4 times the 4 plus my y1 value, which is 8. This one comes out a little bit nicer. So 3 plus the 8, I get 11. That is the y-coordinate for point P. So point P is at the point 1 and 3/4, comma 11.